Okay, so daily lessons, page 137. Because you didn't really want to just see me typing this, I typed this out already, and you can stop the video and take a second to write this down. But the definition of net distance is the final position minus the initial position, which is the shortest path. And the definition of total distance is the distance of an actual path. So you're going to take some time, stop this, and then, come back to me in a second. Okay, so you're back. If a particle is moving in the same direction the entire amount of time. So what this is meaning, the difference between net and total, is let's say I'm walking here, and this is my initial position, and I walk for a couple minutes. And I walk this way, and then I walk this way, and then I decide to walk this way, and I walk this way again, and I walk this way, and I walk this way, and I wind up in the exact same place I started. If I wind up in the exact same place I started, my net distance is 0. I didn't go anywhere. My total distance is that total number of steps I took. So I would have to add up if I took 2 steps the first time, 2 steps the second time, 2 steps the third time, 3 steps the fourth time, whatever it is. I would have to add up all those other distances. So it doesn't matter if I'm moving left, right, whatever. It's just I have to add up every piece of that. So if a particle is moving in the same direction the entire amount of time, net distance and total distance, if I start at point A, and I end over here, and let's say I went 4 feet. My final position minus my initial position is going to be 4 feet. That is going to be my net distance. My total distance, I walked from here to here, 4 feet. Same thing. So if you're moving the same way the entire time, your net distance equals your total distance. Okay, so moving on. To find the net distance, it's easy. So when you see net distance, you should be excited because you've got final position minus initial position. Total distance is going to be a little bit different because you're going to have to find each place. So let's say on some interval from A to B, I walked in a positive direction. So I walked and I get a positive 4 feet. But then I walk back to the left and I go a negative 3 feet. That doesn't really make sense. What I'm going to do is I'm going to add up the absolute value of each distance I walk. So 4 and 3. You should be able to see that better on some examples though. Okay, so in this one, the position of a particle is given by this function where P of t is measured, not measures in, but either way, in centimeters. Find the net distance and the total distance from t equals 1.5 to t equals 4 seconds. Okay, so in this one, net distance is easy. Net distance is the one right away you should be thinking, okay, I got this. This is P of 4 minus P of 1.5. That's it. You find P of 4, you put in 4, you put in 1.5, and you find it out. And you say, okay, well, P of 4 minus P of 1.5, I already did this, so, you can do this now. But you would get 64 minus 5.25. And altogether, I get 58.75. By the way, if you answered like that, I would say, fantastic, you're not right because you don't have units on it. So in this one, if you're talking about P of t measures in centimeters, I'm taking centimeters minus centimeters, I get 58.5 centimeters. Net distance. We're done, yay, with net distance. Total distance is a little bit harder because you need to figure out, is the particle moving left or is it moving right? The only way that I can figure out if the particle is moving left or right. Think about it, tell the person beside you, when is a particle moving to the left? When velocity is less than 0. A particle is moving to the right when velocity is greater than 0. So, I need to figure out, well, when is velocity equal to 0 so I can see if there's any switches in here. The only way I can do that, given position. If I have position, the derivative of position is velocity, the derivative of velocity is acceleration. So, I'm going to take the derivative of position, and that will give me velocity. I should have written this first one. What was I thinking? Okay. Caleb would say, you weren't thinking at all. Okay, P prime of t is equal to V of t. So I'm going to find the derivative. I get 6t squared minus 12t plus 8. Okay. Okay, so what I need to do is I need to set this equal to 0 then. And you can factor this one, maybe, well, you can factor out a 0. Or that doesn't make any sense. You can factor out a 2. And I get 3t squared minus 6t plus 4. Take a minute, try to factor it. Oh yeah, that's right, you can't. You can't factor it, and then if you would try putting 3t squared minus 6t plus 4 in your calculator, it actually never equals 0 for time t equals 1.5 to t equals 4. It's very sad, but you know, it doesn't. So in this case, I want to know, well, is p prime of t greater than 0 or less than 0? So on this thing, because it never changes, p prime of t, if I put in any value into here, so if I, like, I don't know, let's say I put in anything between 1.5 and 4, so let's say 3, and I put it in this value, I'm going to get a positive answer. So p prime of t is greater than 0, and for any place there. It's always greater than 0 because it has plus 4 too, so you could have figured out where the quadratic would lie. But we've got p prime of t is greater than 0. That means velocity is always greater than 0. If velocity is positive, what does that mean about the particle's motion? Tell the person beside you. Okay, that means that the particle is moving to the right. Therefore, the particle is always moving right. And we set up above. The net distance equals total distance if the particle never changes directions. So therefore, net equals total distance. And they both equal 58.75 centimeters. We did it. So take a second, write this down, pause me if you need to, but there you go. Okay, I'm going to continue on just because these are on the same track. So daily lessons, page 138. And by the way, there is a YouTube video besides this one. It's amazing. I'm probably getting so many hits right now, you know, getting lots of followers. There's a YouTube video that's all about a particle's position function. It's by Integral Calc Girl. She's the one that says, hi there. But super, super, super helpful. It's a review of old material from like 0 to 8 minutes, but from 8:34 to 13:17, it's new stuff. So if you're still not getting this, go back there and look at particles, all about a particle's position function. Okay, so the position of a particle is given by this function, where p of t is measured in feet. I don't know why it says it is measured in feet, but you know, we got this. Find the net and total distance. So, net distance is the easy one. All I do is I take the final position minus the initial position. That's it. Nothing crazy. I'm not throwing anything at you. I'm not trying to tease you or trick you in any way. It's just p of 1.5 minus p of 0.5. If you do that, you get 8 point. That's not right. Hold on. Oh yeah, we go. 8.0855369. I'm using all decimal places because I'm not my final answer. Minus 1.2817, and you get 9.367. Be careful about this. It's measured in feet. If this were negative, you would make this a positive distance because distance is always positive. But if I start out to the right and then I move to the left, my answer would end up being negative. So you would just take the absolute value. But for right now, 9.367 feet. Okay, because the last one was really easy and net equaled total, this one probably not so much. So I'm going to check it out. I need to know, does the particle change directions? In order to figure out if a particle changes directions, you need to know when is it moving left, when is it moving right. So, in this one, I need to find the velocity. If the velocity is positive, that means the particle is moving to the right. If it's negative, moving to the left. So in this one, I would say p prime t, I know is the same thing as velocity. So I'm going to take the derivative. E to the 2t is e to the 2t times the derivative of the exponent, which is 2, minus 8t, the derivative of 8t is just 8. And I need to see, when is this equal to 0? 2e to the 2t minus 8. I can factor out a 2 if I wanted to, or I could just add an 8 to both sides. Divide by 2, I get 4e to the 2t. Oh no, I've got e, that's okay. So I would have the natural log of 4, the natural log of e to the 2t. Natural log of e cancels out, so I get ln of 4 plus 2t. Divide both sides by 2. Gross, but you know, I'll take it. So the natural log of 4 over 2. And if you check that, it is in the interval from 0.5 to 0.1 or 1.5, just as you were hoping for. This would be a calculator problem, but I wouldn't necessarily say that you should simplify this or try to put it into some form where you can figure out that this is 0.693144718, because you have to use so many decimal places until the last. What I would say is, as you're using this, you can either store this in your calculator, you can do something with it, but keep it as natural log of 4 over 2. And be careful when you're putting that in parentheses and all that good stuff. Okay, so what I need to do is I need to figure out, I know I'm starting at 0.5. And then I could be changing directions. I don't know if I am for sure. I could make a chart and figure it out. And this one, by the way, if you do that,